All right, hello 8th grade. We are talking about acids and bases today. Just some very, pardon my pun, basic information about acids and bases. So first we're going to talk about the properties of acids and bases, and the first thing we're going to talk about is acids specifically. So an acid will produce hydrogen ions, or H plus ions, in H2O. H plus ions are also known as protons in the atom because they're just like a positive charge. So that's another way to call it. You could call it H plus, you can call it hydronium ion, you can call it a proton. It's the same thing. They generally taste sour. They turn blue litmus paper into red. And I will show you guys a picture of that in a moment after we go over bases. They act as electrolytes in solution, which means that they are able to carry electrical charge. They neutralize solutions containing hydroxide ions. So you have basically H2O can be separated into two kinds of ions, which are your hydronium ions or your H plus ions, and then your hydroxide ions, which are your OH minus ions. And so acids will have more of the H plus, and then as you'll see later, bases have more of the OH minus. So if you add an acid to something that has a lot of OH minus, you will get a neutral solution. And here are your characteristics of bases. They produce or cause an increase in hydroxide ions, as I was just saying. So just to reiterate, acids, H plus, bases, OH minus. Acids, hydronium, bases, hydroxide. They generally taste bitter, so you have your acids that taste sour, and then you have your bases that taste bitter. They turn red litmus paper blue. So there's two types of litmus paper that I'm going to show you in the next slide. They also act as electrolytes in solution. And then they'll do the opposite of what an acid does. They'll neutralize a solution containing hydrogen ions. And they'll have a slippery, soapy feel as well. Alright, so this is what I'm talking about with the litmus paper. So on the left you can see that there is red litmus paper, and then where the arrow points is where we dropped base. So that red paper will turn blue, and then the blue paper, which is blue litmus paper, when you drop acid on it, will turn red. And then just to make it super clear, on the right, we have a base being dipped in, we have red litmus paper and blue litmus paper being dipped into a base. And so if you dip blue litmus paper into a base, nothing will happen to the litmus paper, it'll stay blue. But if you dip red litmus paper into the base, it'll also turn blue. So whatever paper you're using, the result is always blue. If you do it on an acid, if you dip red litmus paper on an acid, it stays red. If you dip blue litmus paper in an acid, it turns red. So whatever litmus paper you use for an acid, the result is always red. So base is to blue, so remember the little B's, and then acid is red. And then neutral solutions will, if you dip both papers in, they'll just stay the same for both. So if it's neutral, it'll stay red if it's in red, and it stays blue and if it's in blue. The pH scale. We kind of went over this a little bit over the last 2 weeks in that reading that you guys should have done. But as I was talking about before, you have your water molecule, and sometimes it splits up into your hydronium and your hydroxide ions, your H plus or your OH minus ions. And when it does that, you can take the product of like the concentration of H plus ions times the concentration of OH minus ions, and you'll get this number, 1 times 10 to the negative 14. This is always going to be like your concentration product for water. And this sort of relates to the pH scale, and you'll see that in a moment. But right now I just want to make it clear that in an acidic solution, the concentration of H plus ions or hydronium ions is always going to be higher than the OH minus. In a neutral solution, they're going to be equal, like we had in water. And then in a basic solution, the hydronium is always going to be less than the hydroxide. So then this goes to the pH scale. So we just saw that exponential value 1 times 10 to the negative 14. And we can think of it that way. We could think of the pH in that way, but it's kind of impractical when we're talking about it in like clinical settings. So we simplify it to this pH scale, which is the acid-base concentration, where P means like potential or power, and H means hydrogen. And so instead of getting these exponential values, you'll get just like integers from 1 to 14. So on the pH scale, values below 7, so everything from, I guess it goes to 0 in this case, but most people would say it goes to 1. Values below 7 will be acidic. A value of 7, which is what water is, will be neutral. And then values above 7 will be basic. So as you can see, some examples on the acidic side would be things like lemon juice, and coffee even is slightly acidic. Then you have your distilled water right in the middle because the hydronium and the hydroxide equal each other. Then on the basic side, you have egg whites as like a slightly basic solution, and you have household bleach as a very basic solution.